Please welcome George Saab.
Hi, everyone. Wow, that was an exhausting run to get here. Whew. Welcome, everyone, to JavaOne San Francisco 2017. I'm very, very glad that we're back here in Moscone this year for the conference. Very pleased to see so many familiar faces. We've already seen a lot of you. I see a lot of new faces, too, which is great. Thank you all for coming. We have a lot of very exciting topics that we're going to cover today. This is an exciting time for Java. As you're aware, we've recently released new versions of both Java SE and Java EE. And this afternoon, you're going to get to hear a bunch of things about those. And we're also going to talk about some of the things that are in the future direction for Java. Over the past over 20 years, past 22 years or so, Java has grown, it's matured, and to the point where the ecosystem and the resources available are really unparalleled in our industry. And while Oracle plays an important part as steward of Java, Java's strength is really something that comes about because of a lot of people in the community getting together, working together, and collaborating in order to make it strong. Our first guests today represent a number of ways that people can get involved in the evolution of Java. And please put your hands together and help me welcome Jackie and Mercedes. OK, welcome. So our first guest today is Jackie Haynes. She represents Goldman Sachs on the JCP Executive Committee. So Jackie, why don't you tell us a little bit about the JCP and how it helps make Java strong?
Sure, thanks. At Goldman Sachs, we have around 9,000 developers working globally, writing critical applications for our business. And many of those are written in Java or run on the JVM. We've been part of the Executive Committee for the JCP since 2011. To me, one of the key ingredients to Java's continued success is the technical specification, and that's really unique to Java. And the JCP provides a way for us to take contributions to that. And that's really the key here, the community involvement.
OK.
And so that happens in two ways. One, we ensure the quality of that specification so that independent implementations can be written by other clients, other people who would like to get involved. But two, developers can propose their own features to Java, get involved in a JSR, and see that come to fruition as part of one of the new JDK releases. And my favorite example of that is the datetime API that came out in Java 8.
Excellent. Thank you. Our next guest, Mercedes Alvarez, comes to us from the Guatemala Java Users Group and also representing JDuchess.
Okay, yes. One interesting thing is communities are environments where we can share, learn, and grow up together as developers. And the JDuchess chapters are precisely that, but for the female sector. It's a way to can we grow up and increase the female participation in the community and in Java technologies. But the most important thing for me about the JDuchess chapter is that it's a way to change the future. Because every female that be part of the JDuchess chapter and having a role model in our society. So we are an example to what can be a women in technology. So we can inspire future generation for joint careers in technology and science. We can say to the world, things can be done in a different way and can be better. So that is me.
Excellent. Thank you. Thank you both very much. As you can see, Java's value stems from support and investment really across the industry. And just as Java is the result of broad collaboration, JavaOne is also something that happens through the efforts and the investment of a number of sponsors. Our next guest in this next section will actually have some words from one of those key sponsors. So I'm very pleased to introduce him. I think he has probably the coolest title I've ever heard. Please put your hands together and help me welcome the VP of Optimization from Intel Corporation, Michael Green.
Wow, this is a really big stage. Good afternoon, JavaOne. It's great to be back. You know, data is the future. Do you remember when self-driving cars and talking computers were seen as futuristic? If not, perhaps you should ask Alexa or Siri. When I was younger, I thought maybe, just maybe, in about 100 years, from then, this would be possible. Well, the world has exceeded my expectations. What I didn't understand as a kid was that data would be the key enabler of such a futuristic world. Data is to this century what oil was to the last, a catalyst of innovation and a revolutionary leader of change. Data is at the front and center of technological advancements, innovation, and business transformation across the globe. Let's take cars, for example. The data generated by cameras, LiDAR, GPS, and in the vehicle itself are essential to automated driving. We're looking at each autonomous vehicle generating approximately 4 terabytes of data a day. Soon, we'll be talking about data in terms of exabyte, points for what comes after exabytes, and zettabytes. Whether individual users or massive enterprises, at every level, data being generated will be exponential from where we are today. This is a total transformation across technology, moving from a compute-centric to a data-centric world. It's an exciting time. We view Java as a foundational technology to unleash the potential of data and bringing in this new future. It's why we're so invested and why we'll continue to be invested for years to come. We believe Intel and Java together will deliver on 3 imperatives created by this data explosion: speed, scale, and smarts. Speed. Performance is everything in a world where the difference between days and months can mean the success or the failure of a business. Or in extreme, like cases in medical treatment, saving a life. Scale. In a world with 20 billion devices as predicted in 2020 as predicted by Gartner, operating at scale is critical to managing their data and their businesses. And lastly, smarts. Artificial intelligence will be the tool that harnesses and converts a flood of data into powerful insights and smarter decisions. Increasingly, these insights will be made not only by people, but by the machines themselves. There's a movie of something about that, machines becoming self-aware. I'm sure you've seen it. So let's talk about speed. Speed naturally improves throughput, which often leads to a lower total cost of ownership. Let's take a look at what Intel's new class of Xeon processors can do for your applications in this video. So our newest hardware, the Intel Xeon Scalable processors, are designed to turn all this data into decisions faster than ever. With the Xeon Scalable platform, Intel is delivering an additional 65% performance boost over our last generation. This is the largest generational gain in performance in the past decade. For emerging workloads like AI, it means doubling the performance of the system. We've also worked closely with leading big data communities to optimize Hadoop and Spark for this newest Xeon platform. The result? A 3x improvement in performance. I stood on this stage last year and told you that a decade of accelerating Java has led to a 73x performance boost, and that we weren't slowing down. I also said that we would continue to add features into Java that matter to you. What I'm happy to say is that these efforts paid off. When we run financial services algorithms on JDK9, on our latest Intel hardware, Black-Scholes is 3 times faster. Monte Carlo simulation, 6 times faster. And for advanced encryption, up to 20 times faster. Putting it all together, our newest Xeon Scalable platforms and key optimizations collectively result in performance gains of 110x over the last 11 years. That's impressive. Intel and Java are simply better together. I hope you're all taking full advantage of what's possible with JDK9 on our latest hardware. Clearly, delivering performance is core to our business. We must also solve the problem of scale, from large data centers to the billions of devices and sensors on the edge. The data generated are growing at an exponential rate, creating a couple of challenges. First of all, data has to be stored and accessed quickly if you want to turn valuable business insights, valuable data into valuable business insights. And secondly, massive transaction volumes require a much more flexible and scalable application architecture. In a world where data is king, computing requires advanced storage and memory technologies. The first is Intel 3D NAND technology, designed to deliver double the capacity at a lower cost and at nearly half the power versus our first generation of 3D NAND. That's good, but we've done even better. Even more exciting is our new Intel Optane technology enabled by 3D cross-point memory media. This is our first memory media breakthrough since the 80s, enabling up to 10 times the density of DRAM. With this new technology, we are delivering a new category of SSDs called Intel Optane SSDs. And these devices really fly. We refer to them as the world's most responsive data center SSD. It's easy to understand why when you compare it to NAND SSDs. It's up to 8 times faster with 40 times lower latency. While that's great, we're going even further. Third, Intel persistent memory will bring the revolutionary Intel 3D cross-point technology that powers Intel Optane SSDs onto the memory bus in DIMM form. You can now remove the overhead of the file system, remove the overhead of the device driver, while keeping the byte addressability of DRAM, all while keeping the capacity and the persistence of SSD. This is the best of all worlds. As exciting as the possibilities are for this technology, programming persistent memory can be a bit tricky in Java. Number one, it's heavy lifting to maintain data structure consistency in a fail-safe way, and it requires access to low-level CPU instructions. To resolve these issues, we're happy to announce the availability of the persistent collections for Java. This provides you an optimized and easy-to-use set of common data structures, including persistent versions of lists, maps, tables, and sets. It also provides low-level functions for the power users amongst you. We have an early implementation of the library along with sample code such as a database example using persistent collections, and a low-level API example. Please check it out, try it in your applications, let us know what you think. We're always happy to get your feedback. Your feedback is a gift. The demands of exponentially increasing data require you to scale across multiple nodes and clusters to manage it all. Whether you're delivering an e-commerce site, a streaming service, or a fantasy sports league, the challenge remains. To talk more about these challenges, I'd like to welcome a friend on stage, Chief Scientist of Alibaba System Software, Kingsum Chow. It's a long walk, isn't it?
It's a long walk.
All right.
Nice to see you again, Michael.
Great. Same to you.
Yeah.
What can you tell us about Alibaba's business and how you're dealing with the challenges of scale?
Well, that's a great question. We are dealing with running with lots of Java applications and running about 100,000 Java applications and 1 million instances. But before I talk about that, I want to talk a little bit about Alibaba because some of you might not be familiar with what Alibaba is about. So let me get started there. Alibaba has a huge e-commerce site in China. In fact, if you look at the economy of our volume of sales, we are about the 22nd largest economy in the world, right behind Argentina.
That's impressive.
Yeah.
So what do you do to address the challenges at Alibaba?
Yeah, it's a great question. So in order to handle all the business we have, we have been using OpenJDK and customized OpenJDK for our own needs. And as we mentioned earlier, we have huge e-commerce applications we need to run and distribute them. Not only that, we also got some help from Intel.
Oh, you're welcome.
Yeah. So we ported several important patches about JDK9 and put them down to the Alibaba JDK system we call AJDK. And it has been running very well so far.
Excellent.
AJDK has been used to support lots of Java applications. In fact, I mentioned earlier that we have 100,000 applications written by 10,000 Java programmers. We have a huge presence in Java. And because of that, we need to customize some of the needs in Java. So we built our own JDK. And right now, we are running about 1 million JVM instances in our data centers.
Wow, that's a lot of data and a lot of compute. So did you have to do anything with the architecture to handle this?
Well, it is a fantastic question. So in order to support the scale we need to deal with, we built something we call the distributed Java services on top of AJDK. And this means that our applications are modular Java services that operate independently of each other. And each Java service runs on a single process and is handled by a layer of communications among them. And these distributed services give us the agility and scale we need.
Wow, so what does that mean in practical terms for your business?
Yes. So let me look at one example here. Let's look at one single day in China. In fact, it's even called a single day. Some of you might have heard about that. November 11th has been redefined in China by Alibaba as the largest online e-commerce festival. And it's called a Singles Day because all these singles, they have nothing else to do, so they go online and take advantage of sales, and they buy a lot of stuff. It's very similar to Thanksgiving in the United States. So let's pull up some numbers and compare them, shall we?
Let's do
Okay.
that.
So last year, the total online sales in the United States on Thanksgiving Day, Black Friday, plus Cyber Monday, the total of the spending there is $12.8 billion. It's a big number. So look at China. People like to buy stuff in China for some reasons. So they generate sales in China on that day, $17 billion. And not only that, In fact, we need to process 120,000 payment orders at the peak of the shopping spree. So what does that mean? So to give you a comparison, a major credit card company that at the peak of the purchasing, they only need to process about half of what we need.
Wow, that's impressive. You know, in order to continue managing the growth of your business, what would you ask of the Java community?
Excellent. So two things. One is...
I'm the straight man, I think.
So one is, the better the hardware performance, the more creative we can be. We can distribute newer services, faster services. So we are very excited about all the performance you have mentioned today.
Hey,
we like all of them.
Intel processors always sounds like a good idea.
On top of that, we are also interested in learning how to use persistent memory in our applications. Secondly, as we mentioned earlier, that we are doing large-scale cluster deployment of our applications. So it would be great to have representative workloads for distributed services that we can model, play with, and then deploy in large scale.
Wow. King Sum, thank you. Thank
You're
you
welcome.
for sharing with us Alibaba's challenges and challenging Intel and the Java community to do even more.
OK. Thank you. Nice meeting you. Bye.
So, as I already mentioned, when it comes to performance and speed, I feel like we're going to be able to take a done on that one. We'll continue to ensure, though, that Intel delivers the absolute best hardware for you and everyone else to manage scale using distributed microservices. While we're seeing an increased focus on microservice-based deployments, such as the one King Sum described, today there's an industry gap when it comes to tools focusing on data movement and storage within and across the system. That's why today I'm announcing that Intel is launching DataBench, a new data-centric workload. The DataBench early release code base is available for download and collaboration right now on GitHub. While the proof of concept framework uses Kafka, Spark, and Cassandra, we've designed it in such a way that you can easily integrate whichever components you're currently using into this framework. Our goal is simple. We want to turn it into a workload that represents the reality of how you really use microservices. So come, help make it happen. So we talked about performance and scale. And now let's talk about smart. When I think smart, I think artificial intelligence. Society is being transformed on a spectacular scale. Machines that sense, reason, and act can accelerate solutions to large-scale deployments. Let's look at one specialized form of artificial intelligence, deep learning. It's fantastic in that it can be applied to big data sets and operate without human supervision for real applications such as image recognition, analysis, fraud detection, customer recommendations, and so much more. In other words, deep learning can be a powerful engine for producing actionable results. But there was a gap when it came to deploying deep learning solutions on the same Spark clusters that many of us are currently using to run big data and analytics applications. I'm happy to say that we introduced Intel's BigDL solution, a distributed deep learning library for Apache Spark, which, of course, runs on Java technology. Here's a video to demonstrate what BigDL brings to deep learning.
Organizations everywhere are developing deep learning applications to derive new insights, identify new opportunities, and uncover new efficiencies. Unfortunately, deep learning application development often means tapping into multiple frameworks, libraries, and clusters, a complex, time-consuming, and costly effort. Now there's a way to greatly simplify deep learning application development, decrease deployment costs, easily scale your applications, and achieve outstanding performance with BigDL. BigDL is a distributed deep learning framework organically built for Apache Spark. That means you can more easily develop deep learning applications as standard Spark programs using Scala or Python, and then run those applications on existing Spark or Hadoop clusters without expensive specialized hardware. Apache Spark enables applications to seamlessly scale across Intel Xeon processor-based nodes on a massive scale. And BigDL delivers extraordinary performance across the Intel Xeon processor-based infrastructure by leveraging the optimized Intel Math Kernel library. Plus, BigDL provides support for rich deep learning and delivers feature parity with popular open-source deep learning frameworks such as Caffe, Torch, TensorFlow, and others. Customers are already benefiting from the power of BigDL. For example, a major financial services firm has developed applications to strengthen fraud detection, and a leading manufacturer is pushing the envelope on improved defect recognition. BigDL could be deployed on a variety of big data platforms. Visit the link shown here to learn more.
Can't get tired of the bong. All right. So BigDL, as you saw, is an open source project. It's available on several cloud service providers, as you can see from the slide. In fact, it's not just theoretical. Companies like JD.com have deployed BigDL with remarkable achievements. BigDL has a growing list of applications and use cases deployed. We're encouraged by the uptake and different use cases being deployed. Please go check it out. We're enabling other capabilities as well when it comes to AI. Among them is the power of vectorization, which we've increased on our newest Xeon processors by adding the Intel Advanced Vector Extensions, AVX 512. Specifically, it can accelerate tasks like modeling and simulation. And at Intel, we've been building this kind of capability into our hardware since the 90s. But as we all know, it hasn't been easy to take advantage of it with Java. I'm happy to say that those days are behind us. And to share more about it, I'd like to welcome on stage Chief JVM Architect at Oracle, John Rose. Good to see you, John. All right. So, John, we've been working together on several things, been doing pretty fantastic performance work together.
We sure have. Oracle and Intel have been collaborating for quite a while now on code quality, persistent memory, garbage collection, and of course the libraries, and as well as the vector hardware you just mentioned. I've thoroughly enjoyed working with Intel's brilliant engineers. And on all of these projects, we've gotten there much faster than we would have on our own.
You know, on that note, we've recently been working on some pretty exciting projects to give Java programmers new tools and programs for Intel hardware. Will you share with everyone what we've been up to?
Oh, I'd love to. As you know, Oracle's OpenJDK project Panama was started to give developers direct access to their hardware. And now we have a new vector API in Panama that does just that. Complicated vector code that used to require JNI and assembly code, all that programming at the low level, can now be done directly in Java. For example, suppose I need to do some image processing. I need to quickly run over my loop with millions of pixels. Of course, I want to use Intel's vector hardware because it can work on multiple pieces of data at once instead of the usual single piece of data. This makes my code run as far as 16 times faster. Now, I used to write my data programming loops in classic Java. The problem was it didn't directly use the vector unit.
We should do something about that, don't you think?
Oh, yeah, in fact, we have.
All right.
In fact, with the Vector API, Java now unleashes Intel's AVX hardware, making it the ideal platform for accelerating deep learning algorithms, machine learning algorithms, financial service applications, scientific computing, you name it. We know that making it easy to add vectorization is incredibly important.
It sure is. So what does it look like to a real developer?
What does it look like? Like you, I'm a developer at heart, and I ask myself the same question. I think we should just show everyone here what we're talking about.
You want to see some real coding, real demos on stage? All right. Well, let's go walk over there and
I got a laptop here.
See what we can do.
We can hook it up to the screen and see what it shows us. All right, look at that. Now, this was done on top of the Panama Vector API. The idea is to transform the color of each pixel of this series of images. Now, for comparison, we'll do it the slow way and the fast way. First, I'll show you the slow way. This is the loop that works one pixel at a time. As you can see, everybody reads code here. This is classic Java. There's a 3x3 matrix in there, and it's doing a transform. OK, here's the fast loop that works with the Vector API. And it does 8 pixels at once. And you'll notice that the two loops look quite similar. This is no accident. It makes it easy to replace one by the other. With this code, I get direct access to the Intel vector registers and operations. Look at those vmul PS instructions in there. Aren't they beautiful?
Hey, let's see what it does.
All right, let's run this baby. All right, I'm going to press the button. I'm going to start up the loop. And what it's doing now is the images are being processed one at a time. Each image you see on the screen represents thousands of individual processing tasks. The gauges on the right-hand side show how fast it's going. And see how fast that top row went? Oh my gosh, it's already finished. Well, why don't we run it again? Meanwhile, the vector loop, the non-vector loop, the scalar loop is chugging along, trying to catch up. Why don't we run it one more time? You know, these vector loops go really fast. You can get a lot more done in the same amount of time. OK, so which loop would you want in your application, right? And you are seeing this correctly. The gauges there show about a 6x speed up. You know, this was really only possible because we work together. And the future is bright for the Java ecosystem because of collaborations like ours. Thank you, Michael.
Well,
and thanks to Intel.
Thank you, John. It is great to have an incredible partner like John and Oracle. So to make this simple, we were really excited by what was able to be done. And in fact, we're so impressed that when I saw how powerful this Vector API is, that I told my team we needed to get it out to every developer right away, even while we're still in development. So I'm announcing the availability of the Vector API Developer Program, accessible today. Go to the URL where you'll find more extensive introduction to AVX technology written in developer-friendly language, meaning you won't understand it unless you're a developer. And you can check out John's image processing code as well. Wow, we covered a lot of ground on how Intel plus Java will enable the future. Speed, we continue to improve performance in our latest generation processors. Scale, we've added new storage and memory technologies to help address the challenge of computing at scale. Smart, with the addition of vectorization that you just saw and machine learning, we've made it easier to use Java to extract insights from vast pools of data. This was all done by providing improvements and code samples to help you, the developer, to quickly take full advantage of the increased platform capabilities. We have an opportunity to usher in a new world, a data-driven world. I look forward to collaborating with you in the OpenJDK community. We are better together. Thank you, and enjoy JavaOne.